Hello, my name is Caitlin Rookey, and this is my program portfolio for the Master's in Applied Data Science degree at Syracuse University in the School of Information. A quick introduction, my background is in library science. I spent 8 years in libraries after completing my degree in library and information sciences. So my handling of data and use of data was slightly different, but I had an extreme interest in using analytics to provide data-driven decisions and learn more skills and coding languages and tools to utilize those skills. So the Applied Data Science program at Syracuse University provides students the opportunity to collect, manage, and analyze data from multiple sources using various tools and methods. This portfolio project and presentation focuses on 4 course projects that help develop those skills. IST 659, Database Administration, IST 707, Applied Machine Learning, IST 652, Scripting for Data Analysis, IST 623, Introduction to Information Security. The learning objectives for the School of Information's Applied Data Science program are: number 1, collect, store, and access data by identifying and leveraging applicable technologies. Number 2, create actionable insights across a range of contexts using data and the full data science lifecycle. Number 3, apply visualization and predictive models to help generate actionable insight. Number 4, use programming languages such as R and Python to support the generation of actionable insight. Number 5, communicate insights gained via visualization and analytics to a broad range of audiences. And number 6, apply ethics in development, use, and evaluation of data and predictive models. The first course project is for IST 659, Database Administration. The final project for this course involved creating a database to house requests made by students to obtain a device. In our instance, it was a laptop. It also included an inventory of devices donated to the foundation and donor information. We used Draw.io to create the logical and conceptual models ahead of table creation, and then we used SQL Server Management Studio to create and populate the tables. After that, we created triggers and procedures to send requests to donors for donations to the foundation when the inventory of devices reached a certain level. This was a large project, so we did divide and conquer. The area that was of interest to me and I had some experience with was creating models. So I tackled the conceptual and logical models with the group using Draw.io and their input ahead of creating the SQL. So the conceptual and logical models were developed to organize the relationships between the various items in the database. So we used the conceptual model to show our business objects and their relationships between them after we had kind of written our problem statement and identified questions we wanted to answer with this database. After finalizing that, we moved on to the logical model, which was more detailed than the conceptual model, and it defined the columns that we would actually use and the keys and mapped out transactions. Reflections. We use the technology provided in the course to develop a data management system that stored and delivered data to the user. Building the system gave us a view of where data scientists retrieve data within an organization and showed that the proper organization and implementation directly impacts the analysis of the data. Completing this course and the final project encouraged me to settle on the data pipelines and platforms track within the program, and I'm currently using the skills obtained in this class in IST 722 data warehousing, where I'm using the SQL knowledge to do some basic troubleshooting as we work on ETL process buildouts. The next course is IST 707 Applied Machine Learning. Our final project attempted to use Garmin watch running data to predict injuries in professional runners. The motivation was to try and use some of the techniques we had learned throughout the class to predict injuries and optimize training for runners based on their training and injury history. We eventually really had to narrow that scope to one specific problem, and that was determining if a variable in the data impacted overuse injury. We leveraged RStudio to conduct the analysis using data from Kaggle. The data was quite unwieldy when we began. It included actual data from the watch, journal entries from the runners that were monitored regarding their perceived exertion. It also came with two data sets, one with weekly analysis and one with daily analysis. We did a lot of exploratory visualizations. The one pictured here is a histogram to show the 7 days ahead of an event, which was the injury, to show the distribution of athletes that were running in the 7 days leading up to the injury. But as a note, there were more than 5,000 rows in which the athletes had run 0 kilometers before their injury. There were multiple occasions where we had to further drill down our areas ahead of predictive modeling. As I said, the data set was quite unwieldy, and our goals were a bit lofty. We did do a decision tree, which showed really very low accuracy. We did tune it, and it improved with smaller sample sizes, but it was not the best way to test out these variables that we thought might impact. The one we tested here was the perceived exertion of their training ahead of injury, to see if that had any impact on the 7 days ahead, whether they perceived they had a high level of exertion versus a low level. In reflection, this project was very unique because we got to work less on a business-centered data set, but work on something that was an area of interest to my teammate and I, which was exercise and running. Though we were not able to solve the problem statement, it was an incredible learning experience to be able to experiment with these predictive models, and it really honed our skills using R as we troubleshooted through this whole process. It challenged us to also adjust our scope as we attempted to wrangle this data set. Though it was not a perceived success, we got a lot out of it. And at the end of the project, it was determined that possibly a neural network would have given us more actionable insights and results, but that was not part of the syllabus for this course. The next course is IST 652, Scripting for Data Analysis. We conducted a group project to analyze Airbnb data using Python. We incorporated additional data from the New York City crime statistics for a more comprehensive analysis. We used this project to highlight pricing trends, term frequency and listings, and see if there were any correlations with crime statistics and pricing. Demonstrated our practical application of Python programming skills in data analysis. We each took on a different area of creating visualizations for this final project. I was a novice to Python, but had a great team that encouraged me to try different packages. The one I enjoyed working with and researched a lot on was the Seaborn package, and I found it to be a really great visual way to show the price distribution for boroughs in New York City, each of the boroughs and their prices for their Airbnb listings. It was a great way to show a high-level executive kind of how that price distribution looks, and it's pretty. Reflection. The final project enhanced my then very novice Python skills, and I explored packages, pandas, and Seaborn to help me visualize findings. And after this course was completed, I felt well prepared to enter the big data analytics course the following term. This project was my first transition from using R heavily in 707 to now using Python. So I was able to do some research and create these visualizations with my team, doing some troubleshooting. I also learned a lot from their versatile backgrounds and prior experience with Python, to include things like maps and heat maps, which I had no experience with in Python. The final course is IST 623, Introduction to Information Security. Our final project required us to research a data breach of our choosing. Our team decided to break down the multiple breaches that occurred at Yahoo starting at 2012. We used timelines to illustrate breaches, responses, and aftermath. Their questionable data handling and security practices made for a really robust and engaging project and discussion during our presentation to our class. Our research involved untangling numerous breaches at Yahoo over multiple years, how it impacted the company, how it might have impacted their sale to Verizon. And there was also significant crossover to the information policy course that I completed the previous semester. So I was able to think more critically about court filings, the SEC actions, and it kind of made me wonder and explore more how more proactive policy and regulation might have prevented events or could prevent future events with other breaches at companies. So the best way to deliver this to our this case study to our class was to first show them a timeline. So in 2012, Yahoo Voice was hacked. In 2013, 3 billion accounts were compromised. In 2014, 500 million accounts were compromised. In 2016, Yahoo announced those 2014 breaches 2 years after the fact. That was found during Verizon's investigations as they were attempting to acquire Yahoo. And Verizon acquired Yahoo then in 2017 for a significantly lower price. In 2018, the SEC announced a $35 million fine related to that breach. In 2019, a class action lawsuit was filed. And in 2022, the class action lawsuit settled for $117 million. That same year, Yahoo filed a lawsuit against a former employee for allegedly divulging trade secrets to his employer after leaving Yahoo. In reflection, these two courses, information security and information policy as well, have directly impacted actions I take in my current position as Assistant Director of Information Management at a local community college district. We handle a lot of sensitive student data and have to follow many guidelines and regulations, and I work directly with data and with departments that handle data. So applying ethics in the development, use, and evaluation of data and predictive models protects the data and the organization from legal consequences, but also these ethical data practices contribute to long-term sustainability of data-driven technology and culture. So tying these into the learning objectives, the first learning objective: collect, store, and access data by identifying and leveraging applicable technologies. That's directly aligned with the work completed in IST 659, database administration. Create actionable insights across a range of contexts using data and the full data lifecycle. That was in both IST 707, applied machine learning, and IST 652, scripting for data analysis. Applying visualization and predictive models to help create actionable insights, IST 707. Use programming languages such as R and Python to support the generation of actionable insights, IST 707 and IST 652. Communicate insights gained via visualization and analytics to a broad range of audiences. All of the coursework, except for the information policy and security courses. Apply ethics in development. Use an evaluation of data and predictive models. That was IST 623, information security. So in conclusion, Syracuse University School of Information allows students to integrate data collection, management, and analysis. The skills learned in this program have given me knowledge to deliver actionable insights using various techniques and nurtured strategies to improve organizational efficiency. As this program draws to a close, I find myself equipped with the skills to address a wide range of problems and the resources to explain observations to a diverse audience of stakeholders. Thank you so much for this opportunity. All of the projects that I have discussed are located on my GitHub portfolio repository. Thank you.